Hi, I'm Gianfranco Spavieri, a professor of theoretical physics. I would like to share with you this video on the speed of light, where I show why two well-known optical experiments disprove Einstein's special relativity and his paradigm of relative time. In 1905, Einstein formulated his theory of relativity based on the postulate that the speed of light in empty space is invariant, i.e., the same for any observer in relative motion. Certainly, Einstein was a genius and was awarded a well-deserved Nobel Prize, but, as he also acknowledged, he made some mistakes. Probably his biggest mistake is the one we are discussing here, related to the invariance of the speed of light. In order to measure the speed of light, Einstein introduced a clock synchronization procedure described below, called Einstein synchronization. We know today that with Einstein synchronization we can't measure the speed of light in one direction or one way, but only the round-trip average speed. In this video, we consider also the important and decisive optical experiment made by Sagnac, showing that the speed of light can be the same for observers in relative motion. We'll start by describing Einstein synchronization, where we measure the speed of light reflected by a mirror. Einstein synchronization makes use of a single clock and a mirror placed at a distance L from it. A light ray, a photon, is sent from the clock to the mirror and reflected back to the clock that measures the round-trip time t. Then the one-way speed of light is conventionally assumed to be the same as the average speed, c equal 2L over t. Considering that, in principle, the one-way speed from clock to mirror can be different from the return speed from mirror back to clock, Einstein synchronization has been criticized by many physicists. In fact, in 1913, the French physicist Sagnac performed an optical experiment and, based on the outcome, claimed that his experiment, called circular Sagnaceffect and shown schematically in this slide to be discussed below, invalidated Einstein's postulate on the invariance of the speed of light. The controversy that followed is still going on today, but more physicists are now realizing that Sagnac was right and Einstein wrong. Indeed, a more recent experiment called the linear Sagnac effect, performed by Wang in 2003, confirms the original Sagnac effect and has the advantage that its interpretation, given by Spavieri in 2019 and 2021, is simpler and the conclusions more rigorous. I consider now a simple example explaining what Einstein means by his postulate that the speed of light is invariant and independent of the motion of observers. Let us suppose that Jasmine, one of the observers, is on the platform of a train station and Albert, a second observer, is on a high-speed train passing by at a speed of 400 km per hour. At the same moment, a faster red train traveling at 500 km per hour overtakes Albert's train. We all agree that Jasmine sees Albert moving at 400 km per hour and the red train at 500 km per hour. while Albert sees the red train moving at only 100 km per hour. Thus, the red train has different velocities relative to Jasmine and Albert. The speed of light is denoted by the letter c, which is about c equal 300,000 km per second, which is very high but nonetheless finite. To clarify the concept of light speed invariance, let's consider an ideal spatial drone, the massless Einstein drone, that possesses amazing properties analogous to those of light. According to Einstein, if his spatial drone had the same properties of a pulse of light, a photon, both Jasmine and Albert would see it traveling at the same speed relative to them. In this video, we see that relative to Jasmine, Albert travels at high speed, while the faster drone overtakes slowly Albert, and Jasmine sees them traveling at nearly the same high speed. However, in this other video, we see surprisingly that, according to Einstein, the same spatial drone is observed by Albert to be traveling at high speed, the same high speed observed by Jasmine. To express this special property of the Einstein drone, we say that its speed relative to Jasmine or Albert is invariant, i.e., the same regardless of Albert's speed relative to Jasmine. Then, for Einstein, the speed of his drone or light is always rigorously the same, invariant and equal to c, for both Albert and Jasmine, even if Albert is traveling at a fantastic high speed, for example, nearly at the light speed c, relative to Jasmine. Einstein achieves the same invariant speed c for all observers by introducing his paradigm of a relative time that adjusts the clock hands of each observer in order to yield the speed c for all of them. Certainly, most physicists agreed with Einstein's view, but many others objected to his postulate. Then Sagnac performed his experiment, described below, and, interpreting the result, claimed that the invariance of the speed of light was disproved. Sagnac's experiment is generally performed on a circular rotating platform, where counter-propagating photons travel along the circumference. Let us now perform an ideal experiment, or thought experiment, mimicking the circular Sagnac experiment, in order to check the validity of Einstein's postulate. This experiment can be described conveniently by placing Jasmine on a non-rotating frame on the Earth's axis of rotation. Instead, Albert is rotating with the Earth at some point on the equator, where, ideally, we have train tracks going around the Earth's circumference of 40,000 kilometers. From the point on Earth where he is standing, Albert sends a train eastbound traveling at speed 100 km per hour and another train westbound at the same speed. Since the two trains travel at the same ground speed, Albert will see the two trains get back to him from opposite directions at the same time, after about 16.6 days. If instead of trains, Albert uses two Einstein drones traveling at the same speed relative to him, he will again see them arriving back at him simultaneously. In the case of two photons bound to counter-travel along the Earth's circumference, if their ground speed is constant, i.e. the same invariant speed c, once more Albert expects them to arrive back at him simultaneously. However, by means of his experiment performed on a circular rotating platform where counter-propagating light pulses travel along the circumference, Sagnac found the very important result that the two light pulses arrive at different times, depending on the rotational speed v of the measuring device fixed on the rotating platform. Thus, Sagnac concluded that, relative to the observer on the rotating platform, Albert, the speed of light of the two counter-moving photons is not the same. In order to understand why the speed of the two photons is not the same in Sagnac's experiment, we discuss here Jasmin's Earth-centered inertial frame. It is centered on the axis of the Earth, and it moves with the Earth in its orbit around the Sun, but does not share its rotation. Our main assumption is that the local speed of light c along the equator is isotropic in the Earth-centered frame where Jasmin is at rest. In this case, as seen from Jasmin's non-rotating frame, the speed of light is constant and equal to c for both photons. However, the speed of light is no longer constant for Albert because he is in motion relative to Jasmin. Indeed, according to Jasmin, since Albert is moving toward the counter-moving photon, this photon reaches Albert before the other photon. Thus, the two photons arrive with a relative time delay, and the result is consistent with light propagation at different speeds relative to Albert, because the rotational speed v of the Earth at the equator is to be added c plus v or subtracted c minus v to the speed c of the light pulses, depending on their direction of motion. In conclusion, as seen by Albert, the two trains travel at the same ground speed on Earth and arrive at the same time. However, the two photons, which travel at the same speed relative to Jasmin, do not have the same speed relative to Albert rotating with the Earth. Reasonably, Sagnac concluded that his experiment indicated that the speed of light is not invariant relative to an observer rotating with a circular platform, invalidating the Einstein postulate. Objections of all sorts were raised by supporters of Einstein in order to invalidate Sagnac's claim that the speed of light is not invariant. Their main weakness is the diversity of the different objections, so that none is convincing. One of the objections made to Sagnac's claim is that the observer is on a rotating frame and not on an inertial frame in uniform motion. However, this objection does not hold in the case of the equivalent linear Sagnac effect, where the observer is in uniform motion, while the result is still the same. Now, let's consider another simple ideal experiment equivalent to the linear Sagnac effect, where Albert uses an ideal Einstein drone, or more simply, a photon that travels always at the same invariant speed c relative to Albert. Let us imagine Albert at point A, sending the photon outward in some direction. Going straight at speed c, after 12 months, the photon reaches point B at the distance AB equal L equal 1 light year from Albert. After traveling 1 light year for 12 months, the drone is programmed to change its direction of motion. For example, is reflected by a mirror placed at distance AB equal L equal 1 light year from Albert, and to start traveling back to Albert. However, at the same moment, after 12 months, Albert decides to change his state of motion and varies his speed by v in a short, negligible time, a few minutes, moving toward the mirror. The two events, photon reaching the mirror at B and Albert at A when he starts changing his speed, are simultaneous for Albert. Because of its spatial feature, the photon, or Einstein drone, is supposed to keep the same speed relative to Albert, regardless of his state of motion, on both the outward and the return trips. Therefore, although he has changed his speed, Albert expects the photon to return to him after 12 months, being approximately at the distance AB equal L equal 1 light year and moving toward him at the invariant relative speed c. An equivalent experiment, the linear Sagnac experiment, see link below, has been performed in 2003 by Wang using, instead of the ideal Einstein drones, light pulses counter-propagating along a closed contour. Considering for simplicity a single counter-traveling light pulse as in Albert's experiment with the photon, the result shows that the return trip time interval is quite less than the outward trip time interval. The equivalent result for Albert's experiment would be that the photon return trip time is considerably less than the expected 12 months, say 10 months instead of 12. The difference is directly related to the change of speed v mentioned above, and the experiment shows that if the speed of light in the outward trip is c relative to Albert, it is not the same in the return trip, being c plus v, i.e. greater than c, when he is moving toward the photon. In conclusion, all Sagnac type of experiments consistently indicate that the local speed of light is not invariant for observers in relative motion. Thus, after more than a century of controversial debates, physicists have now started slowly realizing that Sagnac was right and Einstein wrong. The speed of light is not invariant and, As highlighted in my previous video on the linear Sagnaceffect, the time paradigm must change once more.